Mars, the last place you'd want to live, has an atmosphere that is 170 times thinner than Earth's, consisting almost entirely of carbon dioxide. Due to its weak atmosphere, the red planet lacks protection against deadly radioactive rays from space, especially from the sun. Practically atmosphereless, Mars struggles to retain heat, resulting in surface temperatures ranging from 20 degrees to 125 degrees Celsius due to its inability to regulate heat properly. The extreme cold nature of Mars prevents liquid water from existing on its surface, although we know there is ice beneath the surface. With gravity about 2.5 times weaker than Earth's, living on Mars would lead to muscle atrophy and a rapid decrease in bone density. Moreover, Mars's surface, covered in fine dust, poses a challenge even for our modern technology, as the dust can enter electronic devices through the smallest openings, causing short circuits. In fact, Mars' soil is not entirely barren, and I'll explain more about this later in the video. Currently, we have no knowledge of any effective ways to produce food on a large scale on Mars. Therefore, if you were to live on Mars, you would largely depend on supplies from Earth for food, water, and clothing. In addition, despite being one of the closest planets to Earth, communication and material transfer with Mars are still very challenging due to its significant distance. Moreover, with no human facilities on the Martian surface, meeting even the simplest medical needs would be impossible. Despite all these challenges, Mars will somehow become our next home. Its proximity to us and the incredible similarity to Earth in terms of essential conditions make it a candidate for human exploration. If we are to venture beyond our current blue planet and embark on a journey to the stars, we need to conduct experiments and develop our civilization on Mars. If we cannot even conquer Mars, which is relatively close and shares remarkable similarities with Earth, dreaming of reaching and colonizing other planets and galaxies would be impossible. Therefore, we must somehow learn to terraform Mars, as discussed in the video on the Brotherhood of Planets. One of the most significant signs of an advanced civilization is the ability to make otherwise unsuitable planets suitable for habitation, and a crucial step in this, at least for known life, is bringing liquid water to the destination planet. However, the water issue in space is now a frequently discussed topic. Today, I want to focus more on the second most important aspect of sustaining life as we know it: oxygen production. If a planet lacks sufficient oxygen in its atmosphere, establishing a long-term human civilization there would be extremely challenging, if not impossible. Perhaps carefully trained astronauts could survive temporarily on the Mars surface with oxygen tanks and helmets and special suits. Still, if we aim to create a mass settlement, we cannot settle for just that. We need to make the inhospitable places on the planet as Earth-like as possible. And this is not only important from a biological standpoint, but also from a psychological perspective. Moreover, if you can solve the problem of producing oxygen on another planet, you can later generate water in situ by combining it with hydrogen. This is why scientists have been researching ways to produce oxygen on Mars for years. Some significant steps have been taken in this regard. For example, with NASA's Perseverance rover, we managed to produce oxygen on the Martian surface for the first time through the Mars Oxygen In Situ Resource Utilization Experiment, known as MOXIE. MOXIE separated carbon dioxide, abundant in the Mars atmosphere, into oxygen and carbon monoxide. However, MOXIE used materials such as lithium-balanced zirconium and cerium-4 oxide, which are not found on Mars and must be regularly brought from Earth. Unfortunately, this is a widespread problem. If we want a viable system, we cannot rely on continuously transporting materials from Earth. Therefore, the crucial goal is to produce oxygen using only materials found on the Mars surface. NASA's calculations suggest that it is possible to send a much larger facility with a 30 kilowatt power unit to Mars, and if successful, It could produce about 17 to 500 kilos of oxygen per year. Considering that a team of 4 astronauts consumes approximately 1,000 kilos of oxygen per year, this system could provide them with a reliable source of oxygen. However, calling a team of 4 astronauts a colony is challenging, especially since MOXIE needs a constant supply of oxidizing material from Earth to continue producing oxygen. Remember that oxygen is not just a gas for breathing. For example, a spacecraft returning from Mars needs about 25,000 kilos of oxygen as fuel to lift off from the surface. Even with no loss or malfunction, and with the uber-sized MOXIE sent along with the team, which has no existing duplicates and is as large as it gets, the 4-person crew will have to wait for at least 1.5 years to return, assuming they manage to return at all. Let's be honest. The idea of being trapped on Mars for 1.5 years is frightening, mainly due to the reasons mentioned earlier. Fortunately, Mars, while not as large as Earth, is still a vast planet with plenty of materials we can use for various purposes. Therefore, the key is to identify which atoms, molecules, and more complex compounds on Mars can be combined to produce oxygen. These reactions, called oxygen evolution reactions, come in many different chemical pathways. From the simplest, such as electrolyzing water to separate oxygen, to breaking down some metal oxides like potassium chlorate at high temperatures with the right catalysts. By mixing a molecule like sodium chlorate with iron dust and igniting the mixture, a chemical oxygen generator can be created. Alternatively, by creating an environment where plants can survive on the Mars surface, we can enable them to produce oxygen through photosynthesis. Considering the rapid development of artificial photosynthesis methods in recent years, we may soon not even need plants for photosynthesis. In short, within the vastness of chemical science, there are many different ways to produce oxygen, and more importantly, each of these categories has thousands of subcategories. Therefore, the real challenge for scientists is to scan through so many possibilities, identify the most efficient pathways, and narrow down the most likely ones. This is where artificial intelligence comes in. Recently, a Chinese research team used artificial intelligence to overcome this challenge and create what they call a chemist AI. To build a chemist robot, researchers trained an artificial intelligence system using millions of different combinations of 30,000 different hydroxide molecules. Subsequently, this artificial intelligence began identifying which molecules on Mars's soil, under the influence of which catalysts, could produce oxygen. Unfortunately, the team did not have direct access to enough samples to analyze Mars directly due to the negligible amount we can bring from Mars to Earth. However, large asteroids colliding with Mars lift a considerable amount of soil into space, and these rocks sometimes reach Earth's surface as meteorites. Experts analyzed 5 different Mars meteorites by laser to identify all chemical reactions with the potential to produce oxygen. Using a Bayesian probability method, artificial intelligence identified a staggering 3,746,376 different ways to produce oxygen through chemical reactions in just 2 months. If a single human were to do this, it would take about 2,000 years to complete the process. Afterward,